to the cloud. All right, so I'll get going. So today we're going to look at actually a COVID-19 report that dimensions a digital science report that we're just about to release. And the reason we're going to look at that is it's been made entirely with the Dimensions API with integration into Figshare and Overleaf. So I'll take you through how we did that. The other reason it's nice to look at is it's a good sort of revision set over the for the 14 sessions that we've done so far. There's probably at least one graph that covers a technique that we've used through them. So it's a nice way of summarizing where we've got up to thus far. So I will start as normal with an introduction to the API and then move into the COVID-19 report. Okay. So if you've never seen the API before, and if you have seen the API before and you've seen this introduction before, you can try and guess what I'm saying along the way. But if you haven't seen the API before, the API is really about getting at the same data set that you can get through the front end, through the back end. And if you can get it via a programmatic interface, then you can use it in your favorite analytical tools. You can use it to automate tasks that will be harder to do for you, would be very repetitive for you to do through the front end. And you can actually use the API to go a little bit further than the front end in terms of getting profiles for researchers and doing a few special things as well. But for the most part, the API is a way of getting at the same information that you can get through the front end of Dimensions. And in fact, the API thinks the same way as the front end of Dimensions. So if you think about what the front end of Dimensions is allowing you to do, you've got search up the top, where you can type in what you're looking for. And when you do that, you're going to get the publications or the data sets, grants, patents, clinical trials, or policy documents that match your search term, and they can be provided to you in different buckets. So we've got a publications bucket, data sets bucket, grants bucket, so on.
Simon?
Yep.
Sorry, are you supposed to share your screen?
Yeah, that'd help, wouldn't it? That would really help. Let me do that right now.
Thank you.
I like that everyone's so used to the description of how the API works that it was just so present in your mind it didn't occur to you to remind me to share my screen. But here's the Dimensions front end. We've got our search bar up the top. We've done a search. We've got our buckets of information through the middle. Now we want to refine that search. We want to say, just give me the publications on plastic in a particular year, and we'll apply facets down the side. So 2009, 2008, we'll limit that. We might choose to limit it by researcher or source title or publisher down the side. So once we've applied those facets, we've limited our data set in the middle. But we also might want to know a little bit more about the information or summaries about the information that we've got in the middle. And for that, we've got analytical views on the right-hand side. So with this restricted to the search that we've applied and the facets that we've applied, we can tell you the number of research publications or data sets by research category. We can choose the different categories that we've got. So we've got many different ones to choose from. We can have a look at an open access profile across the same data set. Researchers, journals, publishers, funders, research organizations, places, and so on. And that's exactly the same way as the API thinks. So if you've got access to the API, you will have in your menu bar up the top here, a little workflow button. And when you click on the workflow button, you'll see the API menu option appear as probably the third option in the items. Now, quite often, we will give you a separate account for your API to your normal account if you're at an institution. And that's because if you're using the API, it's likely that you're going to be leaving your username and password lying around in text files. And that's not something institutions would like to encourage you to do with your single sign-on details for, say, your HR system or your finance system or everything else that you might want to access. So it makes sense to get a separate account for your API. But the API account itself will work exactly the same way as your normal Dimensions account. And you can use it to sign into the front end of Dimensions. And when you do, you'll see an API button here. if you click on this screen, this is probably a nice way, A, to verify that you've got access to the API and get a good sense of how the syntax of the API works. So here we've got search publications and full data for. That's the equivalent to our search bar up the top. Where we're going to now select our facets down the left-hand side. We're year in 2013 and type is open access. And we're going to choose to look at publications. So that's our bucket down the middle. And then we're going to actually ask for some analytical functions as well, analytical views as well. So in this case, we're going to get a summary of research orgs and funders. So if I just add that over here, you can see that the API syntax works exactly the same way as the front end. There we go. So if we run that, we're going to get our query back and in machine readable JSON, which is intelligent. You can read it as a human being, but as you'll see in a moment, we use a whole lot of different libraries over the top of that to not have to worry so much about processing the JSON object. But you can see here, here's a funders object. It's got a listing of the funders in it. It's got lots and lots of different details about the individual funders, including the grid ID, their longitude and latitude, different attributes. We've got a similar sort of treatment of research organizations, and they're the research organizations associated with the researchers who are affiliate and their affiliations. And then our publications bucket, lots of information about our publications. The details that you see in this publication data set have been specified in the query. So we've actually explicitly asked for these items, and there's lots more that you can ask for. And the way to find out which items to look for is either to make a mistake with the query, because then it will tell you, I couldn't find this, but here are all the other things that you could be looking for. Or you can use the API documentation in the right-hand corner. So if we have a look at the API documentation, it is excellent. It takes you step by step through all the different things you can do with the API. It has sections on what the data sources are, different examples, and it's a really good way of getting to know how to use the API. The other excellent way, if you're an examples person rather than a read the documentation person, and I kind of fall into that category, Michaela has curated a really wonderful Dimensions API lab with lots of different examples of how to use the API with his Dimensions client in Python and Jupyter Notebooks. So if you click on these, you go everything from the very basics of how to get started with the API through to doing quite complicated tasks, as Michaela was showing you in the last two sessions on analysing journal outputs. So that's probably a good place to end with just an overall introduction to the API. When we use the API, we tend to use it inside Jupyter Notebooks or R sessions. So I will show you how we've been using it in here, in the particular case for the COVID-19 report that we're going to be looking at today. So in this report, it's quite strange that it's going to that screen. Maybe it's going to, oh, I was just impatient, that's my problem. Wait for it to log up in a tab. Whilst it's, there we go. So in the COVID-19 report, we've actually done an analysis using the Dimensions API, and I'll just give you a sense of how that works. Okay. So for instance, in the first query of the set of analysis we do, we run with our Jupyter Notebook. We, in the first sense, we put in the libraries that we want to use for Jupyter Notebook, and the most important one for Dimensions is the Dimensions client library, dimcli. Then we log into the library, and we can either have our username and password in a text file that we can establish using dimcli init on the command line, or we can, as you've seen in many examples over the past 14 sessions, you can also input that directly into your notebook. And then we run a query. So in this case, here's a query for COVID-19 articles that replicates the COVID-19 front-end search that you can do in Dimensions. Search publications in full data for any of these matching terms, where year is 2020, and I want this information from the publications. And so instead of running it in the Dimensions front end, I run it in my client, and I get the information to come out. So as you can see, I am now using the Dimensions client. I'm putting in a query. In fact, I'm using query iterative because I want lots and lots of results. With the Dimensions client, you can get up to 50,000 records, which we're actually seeing the limit of with the COVID-19 publications. 40,000 publications this year is amazing. That is probably equivalent of 2 large size institutions already this year for COVID-19 research, which is pretty amazing. Okay, so as you can see, this is the analysis project that I've used for the COVID-19 papers. I'll take you to the front end, and then I'll walk through all of the examples that we've used through the paper. A lot of them you've seen before, so we've talked about looking at network diagrams, we've talked about analysing policy documents and journals and grants before. So really it'll be a rehash of what we've been looking at in the context of COVID-19. So here's the report. The report we did in Overleaf, and you can see that we're still currently working on the report. Here, the bulk of the report was done by Daniel and myself. And then because Overleaf is a fantastic environment for collaborative editing, it's then been edited by the team. We've had marketing go in, identify the call outs, and we've been able to apply the entire report, the digital science report template in Overleaf, which is kind of special. The other thing that we've been able to do is we've been able to link back from Overleaf to Figshare, where we store the figures and the data sets, and those go back to the notebook that I'm using in Jupyter. So if we have a look here at the finished product, here's the report. The first thing we notice in the report after Daniel's introduction section is just the sheer amount of data that's coming in from COVID-19. So this is a report that we've pulled directly from the API, and all it's saying is, can you break down the number of COVID-19 papers by the date that we first knew about them in Dimensions, so the date inserted. So if we have a look at that data set, so you see this links to Figshare, we can pull up the code for it here. And we can see all we're doing in this data set, in fact, it's the one that I was just running there, is we're search for COVID-19 articles, and we're looking for the date inserted as the main thing that we're pulling out there. And we're now going to analyze that data. So we're going to end up with this graph, which is the same as that one. And all we do is we take the information that we've got from the API. We use Michaela's wonderful Dimpley library to turn that into a pandas data frame, which is spreadsheets for Python. And then we just aggregate that data by date inserted. So here, and we group that information up into a graph, which is this one here. And we've just overlaid over the top of it the type of publication. So that's the first graph we've got, and you can see that's an amazing set of information from Dimensions. Almost no other data source is tracking COVID-19 like Dimensions is. It's quite spectacular. So if we go down to the second graph we're having looking at, it's actually the same graph here, but instead of broken down by day, it's broken down by week. And so by week, you can start to see a really interesting pattern coming through the data. You can see that over time, by far article types is the most common prevalent way of publishing in COVID-19, but preprints are extraordinarily strong. So if you think about it, COVID-19 research is medical research, and before this year, there was negligible use of preprint servers like medRxiv or bioRxiv. In the COVID-19 research set, that usage has gone up to at least 16 or 18%. In fact, it peaked in about March, proportionally to the number of articles, and it's dipped down a little bit. We suspect it's dipping down a little bit because more and more different fields of research are getting involved in COVID-19, and they have their own preprint patterns of usage as well, so it's diluting the effect. The next thing we had a look at was being able to use the API to analyze that same COVID-19 data set in terms of closed, open, and the different sorts of open access statuses that you can get from Paywall. Now, this was slightly tricky for COVID-19 research, and the reason for that is that because we're basically analysing the bleeding edge of data that's coming into Dimensions, and Dimensions is hooked into the rest of the publishing workflow, so Crossref, Unpaywall, and all the rest of it, we're relying on those systems as well to be as up to date as we need them to be. And quite often there's sort of a synchronization problem. So if we have a look here, what we actually found was when we're analysing data within the last 2 weeks of Dimensions, we were actually seeing things in Dimensions that looked like they were closed, but in fact they were open. And it wasn't really the fact that they were closed or the fact that there was a discrepancy in Dimensions. It's just that Dimensions hadn't caught up with Unpaywall to synchronize the data. So we went actually in this notebook here, we actually go back out to Unpaywall and get the Unpaywall dates directly, because we don't want to wait the week it takes to very reasonable amount of time it takes for Dimensions to update its data. So you can see, if I can, you can't see at the moment, you can just see a big long screen of numbers. Down the bottom here, I think, somewhere. There we go. So this graph is the graph of the difference between the Unpaywall status in the Unpaywall's API and the status in Dimensions, and you can see there's some discrepancies in the last couple of weeks. So the first discrepancy is that Dimensions just hasn't got around to querying the Unpaywall data, and there could be a week's lag. And the second one is that Dimensions might have queried Unpaywall before Unpaywall worked out what the status of that article is. So you can see that there's this bump of records here that perhaps haven't been assessed by, haven't been connected to Unpaywall from Dimensions. And then there's probably a second bump here where Dimensions has asked Unpaywall, but it will take a second querying of that information to actually synchronize that data set. So when analyzing COVID-19, it is a fire hydrant of information, and you do have to be a little bit careful of what's coming out in the last week or so to get the data right. So the other thing I think we did talk about initially was being able to look at the affiliation data inside the COVID-19 articles. The session that we didn't record was about COVID-19, and we did cover working out how to do weighted affiliations, but it's worth covering that approach again. So what we're doing here is, again, we're querying out the COVID-19 papers, and then we're basically counting them up like weeks, just like we did in the graphs above here. But the difference is we need to work out for a given paper what percentage of it was written by China and what percent of it was written by Germany and the US and so forth. So what we do here is we make use of, see if I can find it very quickly. We make use of Michaela's ability to turn a data set into, if I just find it, dot as authors. I'm going to find it for me. Zoom is getting in the way of my. I won't find it, and I'll be drowning in trying to do the search find. But basically what we do is we make use of the function in the data frame, which basically allows us to, it's up the top here, that's why, turn a data frame that's about publications into a data frame about authors and their affiliations. So using the Dimensions API, the DIMPLI library, you can say, turn my results into a data set of all the different researchers and who they are affiliated with. And from that, you can calculate fractional counts and then re-add up the data again, which is what that table is there. So the next thing that we looked at was the different behaviors of, so I should pause and show you what the story is on that one. The story about that graph is quite interesting. What we found is that in initial weeks, the activity was mostly around Chinese research. And then coming up through March, we've got an increase in US research and then an increase in Europe and indeed an increase in the rest of the world. And in fact, China levels off and just consistently contributes, but doesn't increase beyond March, which is quite interesting. So we're seeing different points of activation between different countries. That's also reflected in the citation data. So if we look at citations by journal, which again is a dimensions query, so we can have a look at that one as well. So all of these, when we release the paper, all of these examples and the example code will be available for you, just like I'm clicking through now. We can see that in this case, we're going to use the coronavirus, but we're going to get a story about journals. And we can see that we've got preprint servers featuring quite predominantly, and also the Lancet and New England Journal of Medicine. And then if we go across, we can see the number of publications is fairly even, with perhaps the US having more publications in these journals, but the citation profile tells a different story. In fact, it's the Chinese articles in these journals that are being cited more. And that is partly to do with the fact that the Chinese literature in COVID-19 research has been around longer. And when I say longer, we're talking months, because that's how fast this field is iterating, has been around longer than the US and the European research. If we go down here, this is a similar view of the information, just making that point. So what we've done is we've had a look at the COVID-19 articles, and we've said, okay, through that set, what you can do with the API is you can ask to pull back reference IDs, and that's saying this publication is citing these publications. So using that, you can say, okay, how many citations within the COVID-19 publication cohort, how many papers have been cited by those references, and you can pivot that information through. And we've got an example of doing that in this workbook here. And when you do, you can see that the citation profile, even through March, is actually weighted towards the Chinese publications, and it's quite different to the publishing platform, publishing pattern. Now, we did go through the being able to have a look at the grid information that you can return from the API. So one of the things you do when you get research organizations or organization affiliations is you can get the longitude and latitude of all of the different countries. So if we have a look at this notebook, what you can do is, this is creating a map of the hotspots of research based on a particular query, in this case, the COVID-19 query. And what we're doing here is we are using the Michaela's Dimpley library to get our author affiliations. And then from those affiliations, we're using our ability to put a list of information into another query. And we're querying the organizations function in the library to get out the longitude and latitude details of all of the different organizations, so that we can put them on a map and join that back into the information. So to create a beautiful map like this, all you're doing is you're getting the list of publications. From that, you're extracting out the affiliations. You're then getting the details in terms of longitude and latitude for each of those organizations, joining that information back up, and then you end up with a plot like this, where each dot is a publication with the longitude and latitude broken down by its authors. And then you want to apply some sort of heat map over the top of it. So one way would be using a KDE plot to give you the areas of focus. And you can see that sort of coordinates here with the different focal areas on this map. what we ended up settling up for is using a hex bin to do a hex bin over the data plot and then map that over a map using some of Python's cartographic functions, which looks very nice. And hopefully this example is easy enough for you to follow. Okay, so we've told a story of geographic location. We've told a good story about preprints and journals. Obviously, we can use the API to count the number of active research institutions that are publishing. So here's a list of the education institutions. Again, using the API, you can extract out the organizations and work out what their type is. So we can break down that list between institutions that are education, institutions that are healthcare. And you can see there's quite a good mixture of Chinese and Western institutions in that list, and similar for healthcare. So the next thing we had a look at is bilateral and domestic collaboration. So looking at the different collaboration patterns going across those data sets. So again, we're querying the Dimensions API. We're saying, hey, Dimensions API, tell me about all your publication, your COVID-19 papers. And this time we want to use the feature where you can say and count number of countries equals 1, because if you have only one country involved, that is by definition a domestic paper. Count number of countries equals 2, that's a bilateral paper. And count number of countries is greater than 2, that's a multilateral paper. So we're using 3 Dimensions API queries to build this graph essentially. And again, you can find the example in the Gigantum notebook as well. And we've covered that previously in these sessions. You can do the same thing at an institutional level too. So you can look at the number of publications that are a single institution, number of publications that use that have 2 institutions, and then more than 2 institutions. The next thing we had a look at is, okay, we've told a story about the types of publications, where they've been published, what countries, and how that manifests over time, and what sorts of collaborations they are. We can now drill down using the API to look at the individual researchers. So we have in the API the ability to pull out different researchers by their researcher ID and tell a story around them. And so what we're looking at here is a breakdown of all the researchers inside, I just randomly commented that section. All of the researchers inside the Dimensions COVID-19 query. And then what we're actually saying is we're going to use our lists technique. We're going to take the list of all the researcher IDs, and we're going to requery to get a list of all their entire publication history. And the reason we're going to do that, and that's a trick we've used before that we've shown you, is that you can work out what the dominant research area of an individual researcher is. So if they have a publishing history of 100 publications, and most of the time they publish in biological sciences, for the purposes of our analysis, we'll call them a biological science researcher. And so we can get a list of those researchers. The other thing we can do using the researchers core is we can work out the publication age of a researcher. So if we can look at using the, be able to search researchers, return researchers, we can get their first year of publication and take the difference between that and their last year of publication, work out how many years they've been publishing for. And we can filter that to look at a set of researchers who you might consider to be established. So maybe 15 years of publication history. And from that, we can get a population of researchers and start telling a story of who's involved in COVID-19 research. So in a similar way, and we did show you how you can do that, you can create a network diagram of all the different researchers collaborating in COVID-19 research at the moment. There's about 50,000 of them. And you can see, instead of using field of research codes here, we're using research and disease classifications. So we can now tell the same story, and we can see that there's a distinct set of researchers in infectious diseases. You can see neurosciences in yellow going through, bioengineering, digestive diseases, lung, cardiovascular, clinical research, cancer, and prevention coming through the graph. You can also look again at not classifications, but countries. And so what you'll see if you flick your eyes between the two graphs is that the layout of this graph is not just determined by the field that they're working in, it's actually determined by the geography that they're working in. So we've got our Italian researchers working together and sort of integrating with your French researchers, your German researchers, UK researchers through to the US and China. Now, any given researcher will have different connections through that, but largely they're grouped domestically, which is an interesting feature of COVID-19 research. So again, really interesting information that you can get directly out of the API. And then finally, the other thing we can have a look at, again, going back to our field of research codes, is the intersection of researchers that have never worked together before. What proportion of, say, in this case, researchers who are biological scientists, what proportion of them have worked with mathematical scientists, and what proportion and what percentage of that are new relationships. So through this, we can get an idea of different interdisciplinary connections that have been made purely as a purpose of COVID-19 research. So we can see that darker color means that almost all of the researchers all of the biological science researchers who worked with mathematicians in the course of COVID-19 research were new connections, which is quite interesting, versus maybe about 40% of researchers in medical sciences working with other medical scientists for the first time. So you get a different perspective on the newness of different interdisciplinary collaborations. And again, you can get to the data and the notebook, which that was calculated in through the Gigantum project. And we did talk about that, I think, 2 weeks ago when we were looking at interdisciplinary collaborations. And then finally, we're looking at the COVID-19 funding pipeline. So here's the pipeline of grants to which COVID-19 researchers are actively engaged on. So if we look at 2020, we can see that say a quarter of the grants that COVID-19 researchers are actively engaged on began in 2016, which means that they're just about ready to finish. So all of that effort that they were working on up till now is free to be able to be focused on COVID-19 research if they so choose. There's about half of the grants that they're actively working on sort of between 2019 and 2018, they're fresh commitments. So either if they want to turn those into COVID-19 facing research questions, perhaps they're new enough to be able to reshape their project design to do that. But in the middle there's a bunch of projects that's harder to turn ship. So we can look at just how that research community responds in terms of serious funding beyond this initial burst in application. How does that community respond, and where is the money coming from, which is another story that you can begin to look at through dimensions. And then finally, we can look at a story about clinical trials. And this is a graph, which is quite fascinating. What we did was, again, we used our COVID-19 search string, and instead of returning publications, we returned clinical trials. And we looked at the collaborating sponsors and what countries they came from. And what you can see is that in January and February, in the dark red there, actually you can't see that at all, it's way too small, but in the dark red is China. So you can see that there's an early activity in the starting in clinical trials that happens in February. And then in April, a similar number of clinical trials start up that are more US focused. So you can see that there's about a lag of 2 months between China starting out clinical trials and the rest of the world, which is quite interesting to observe, and it will be a serious story to dig into. And that's pretty much what I want to talk to you about. I mean, if there's anything I'd like you to go away with in terms of this presentation, is that you can do a lot with the API, and you can tell a really deep story about what's going on. And this report that's due out next week is a really good example of all of the different things you can do with the Dimensions API, and how you can tell a story in a response to quite quickly in a response to a problem that's emerging. And it's a report that you certainly couldn't do with other sources of information as well. So I'm quite pleased with that. So I will stop yapping and see if there's any questions. I've lost my little bar. Where's my little bar gone that tells me if I've got any questions? Zero questions. Okay, so that's pretty much it for the report. We've got a few minutes if anyone's got any questions about what the specific questions about the API or what they've been working on at the moment.
There is a question for you in the chat there, Simon.
Ah, I've missed it. Brian, do you want to read me the question? I can't get it up on my screen.
Sure, it's from Rita, and she asks, is the report available yet? It's dated June 2020.
The report will be available next week, so it'll be coming out fairly shortly. We're just working madly to dot the I's and cross the T's on the information at the moment.
So am I right that in looking at this, effectively all of the data is live, so that when you publish the report next week, the way that you've integrated from Overleaf into Gigantum, etc., means that the data is all up to date and at that point, rather than you needing to pull everything together in advance, or is it still need to be output to a Figshare when you take a cut?
It will be a static report, but we've developed the library so that you can rerun your data inside the notebook, and that will immediately push it through to Overleaf. So it's not an onerous task to update the data in the report. And probably what we'll do is between now and very early next week, we'll rerun the data and take a snapshot. It boggles the mind that you have to do that with bibliometric analysis, because normally we are a culture that analyzes things on a yearly basis, not a weekly basis.
Yeah.
So
it's interesting though, because the way that you've got it set up effectively, I think, allows you that you could regenerate this in, say, a month's time as an addendum and publish that with some commentary around what's changed without needing to go through the same work to do the analysis, because using the API is effectively a program that you can rerun. Yeah,
that's exactly right. Yeah. It'd still be, yeah, as you said, the analysis will probably change, and we need to check that the things that we thought were happening did actually happen, but the data and the tables would certainly regenerate all by themselves.
Yeah, very good.
Lovely. Okay, well, I will stop the recording now. I can find the record. Where's the record button gone? We're sharing. There we go. And the chat. Good. Okay, I will stop the recording and say goodbye.